I'm going to do the electrolyte evaluation demonstration, and I'm going to show you something before we get going on the data, and that is I'm going to show you what happens when you put sodium chloride in water. Sodium chloride is an ionic compound, so when I put it in water, the crystals, you see what happens? They break apart. And some of them are floating off the screen there, but those particles are the ions, and so we have a bunch of charged ions floating around in solution, and that is the key to conducting an electrical current, is to have ions floating around freely in the solution. And the more salt I put in there, the more ions I would get. Let's try the same thing and see what sugar does. Okay, so this is sugar, big old molecules, and when we put those in water, they do dissolve, but what you're seeing is each one of those big chunks is one molecule, and so there are no charged particles, it's just molecules bouncing around, and that will be important when it comes to looking at if it can conduct a current. Okay, now we're ready to start collecting data. So I'm going to start with distilled water and show you what happens. Now this apparatus, the way it's set up is that the battery has electricity running through there, but it's not a complete current, so no electricity will run through the light bulb unless electricity can flow between the green and red electrodes. So I'm going to put these down into our distilled water. And because no electrical current can travel between those electrodes, the light bulb does not come on. So I don't see any little rays of light coming on. Let's look at what happens with tap water. Now, distilled water theoretically is pure water. Tap water has something in it. So what do you think tap water will do? Okay, I've got my tap water now. Let's see what it does. And I get, on that light bulb, do you see those tiny little yellow lines? That's showing us this would be a very dim light. And honestly, it might depend on how much voltage you have, that you might not see any light at all on this one. Tap water does have some ions in it, like magnesium and calcium ions, that could conduct a current, but they're very dilute. There's not very many of them. So next we're going to try our sodium chloride, and you remember what it looked like when we had sodium chloride dissolving in water, how we got some ions. Now we're going to do 1 molar, that's what that M is, molar sodium chloride, and 0.1 molar sodium chloride. The molar is the concentration, so 0.1 is a more dilute solution, and 1 is the more concentrated. It looks like we're starting with the more concentrated one. So this is my 1 molar sodium chloride. Let's put our electrodes in, and we get a very bright light. So unfortunately this light bulb doesn't turn yellow. We just get those lines around it, and they're really long. That's about as bright as this gets. Okay, so let's go to the 0.1 molar, and as you know, 0.1 is less concentrated, so that's going to mean there are fewer ions floating around. Let me switch to my 0.1 molar. Okay, I've switched to the 0.1 molar sodium chloride, and like we said, it's a lower concentration, so there are going to be fewer ions that are floating around. And we can see it lights up, but this is like a medium light because with fewer ions, there's less to conduct a current. Ions are the key. The more that you have, the more it will conduct. Okay, it looks like next we're going to do sucrose. And remember a little while ago I had the sugar in there, and sucrose is a sugar. It's a covalent or molecular compound, not an ionic compound. So let's switch to the sugar. Okay, so sucrose, again, is a covalent compound. As I showed you before, when it dissolves in water, it just breaks apart into individual molecules, not down to the ion. So when we put our electrodes in, this is 1 molar sucrose, which is concentrated, but I get no light because there are no ions. Let's see what happens if I use the more dilute sucrose. This is the 0.1 molar sucrose. So more dilute, still just molecules in there. We don't have any conductivity, no light at all. Okay. Next, we're going to do hydrochloric acid. And hydrochloric acid, it looks like, because it's HCl, it looks like it's non-metal, so you would expect it to be molecular. But acids that start with H, like that formula, they act ionic when you put them in water. So let me get my hydrochloric acid. Okay, this is my hydrochloric acid. I'm starting with the 1 molar hydrochloric acid, and it's very bright. So this is a bright, it'll be about the same as the 1 molar sodium chloride because they have the same number of ions. The type of ion does matter a little bit, but this is very bright. So what do you think will happen if I go to the 0.1 molar instead? Let me get that ready. Okay, I have my 0.1 molar hydrochloric acid in there. Let's see what that is. So it's a lower concentration, but it is something that forms ions. So this is like a medium light. Again, we have ions in solution, but not super concentrated, not as much. Okay, next we're going to go to glacial acetic acid. Okay, so next we're going to do glacial acetic acid. Now, acetic acid is in your notes as being a weak acid. That means that when you put it in water, it does not totally ionize. Most of it will stay in the molecular form, and some of it will break apart into the ions. So you might have an idea of what it'll do as far as conducting a current based on that. Now, let me tell you about glacial acetic acid. Glacial acetic acid is the pure stuff. It happens to be a liquid. It has no water mixed in with it. And so let's see what you think. It has, again, it's a weak acid, but no water. And it does nothing. And so the reason for this is that when something ionizes, water helps that happen. The water that's there kind of helps pull apart the ions. And so without any water present, this does not conduct a current at all. Let's try our dilute, our 0.1 molar acetic acid. Let me get it. Okay, this is the 0.1 molar acetic acid. Whenever you see molarity, like the 0.1 molar or the 1 molar or whatever, that tells you that it has water in it. When we do use molarity, the solvent is almost always water. If it's not water, it will be specified. So I know for sure this has some water in it. I also know it has a weak acid, acetic acid. It's also a pretty dilute solution. So what would you expect? And we get a very dim light. And that's all you need for your electrolyte evaluation.